Okay, today we're going to talk about vertex form of a quadratic. So if you think back to first semester, when we were first learning about writing the equations of a line, we learned that there were three different forms that were commonly used to write the equation of a line. We talked about standard form, slope-intercept form, and point-slope form. That same concept applies to the idea of a quadratic. There are actually three main forms that you're going to see a quadratic equation or a quadratic function written in. The first is standard form, which you can see here, but that's the form that we have been working in so far. The next form is vertex form, which we're going to specifically focus on today. And the third form, which you actually won't see until you get to Algebra 2, is called intercept form. So three different forms, just like there were three different forms for writing the equation of a line. And just like last semester, each of those forms has different perks or different things that help us and enable us to identify different information quickly. So we learned that we can use standard form with x equals the opposite of b over 2a to find the value for the axis of symmetry, and that we could plug that value in to find the y value so we could write the vertex. And then we talked about how to graph using all of those pieces of information, putting that vertex in the middle of your table. The beautiful thing about vertex form, which you're going to see right down here, f of x equals a parentheses x minus h quantity squared plus k. The beautiful thing about that is we can immediately tell what the vertex is. That's why it's called vertex form, because you can tell right away what the vertex is. The vertex is going to be h comma k. So notice here it says x minus h. So the x value of the vertex, which we also know is the axis of symmetry, is going to be the opposite of the number that you see inside with x. And the y value of our vertex is going to be the k number that's actually on the outside. So unlike with standard form, where we actually have to do some mathematical computation to find the axis of symmetry in the vertex, if you have a quadratic function written in vertex form, you can immediately tell what those two pieces of information are. Your axis of symmetry is going to be x equals h. Don't forget that you need to write it as an equation, x equals, and our vertex, which is going to be the opposite of what we see inside, which is h, comma k. So let's start by just using vertex form, looking at an equation that's already in vertex form and seeing how we can use that to identify information. So here we have three examples. They're already written in vertex form. I can tell that they're already written in vertex form because I don't see an ax squared plus bx plus c sort of situation, which is what standard form is. So I'm going to just rewrite what vertex form is down here on the bottom. F of x is a times x minus h quantity squared plus k. And then if I look up at the directions, it says given the quadratic equation, or the quadratic function it should say, in vertex form, identify the axis of symmetry in the vertex. So let's just, for each of these problems, identify the axis of symmetry. The axis of symmetry is always going to be an equation, and that equation is always going to be x equals a number. So I'm going to go ahead and start that off for each of these problems. Our axis of symmetry is going to be x equals a value. And that value is the opposite of what we see inside parentheses with x. So right now I see x minus 5 inside. So minus 5 is the opposite of h, which means that h is actually 5. On number 2, I see x plus 1. So plus 1 is actually the opposite of what my value for h is. So x equals negative 1 is going to be my axis of symmetry for number 2. Now for number 3, this one looks a little bit different because it doesn't have any parentheses. And I think for some of you, it actually might be easier for you to rewrite this with parentheses just to be able to identify each of your values. So now that I have these parentheses, I think it becomes more obvious that what my h value is here is going to be 0. Now, by finding the axis of symmetry, I actually just found the x value of every single vertex that I'm going to be identifying. And what we learned when we first learned about finding the vertex is that we could just plug in that x value to find the vertex. But now we don't even have to do that because the vertex form tells us that this k value, the constant that's outside, that is going to be the y value of your vertex. So here, that value is going to be 1. And if you think about it, if I plugged positive 5 into this right here, that's going to make the inside 0, which means that that whole first term is going to be 0. So it does make sense. If I plug in 5, I am going to get 1. But we don't actually have to do that calculation because vertex form tells us that this k value is the y value of our vertex. So on number 2, that value is going to be negative 3. On number 3, that value is going to be positive 1. So I have now identified the axis of symmetry and the vertex for each of these 3 examples. And that's why vertex form is the preferred method to use, and that you're going to use vertex form a lot when you start dealing with transformations and quadratics in future classes. So it's all well and good that I've now told you why vertex form is helpful and how to identify different parts of a quadratic function from vertex form, but it doesn't really help you if you don't know how to put an equation or a quadratic function in vertex form. Every single quadratic function that we have worked with so far has been in standard form. So that should lead to the question, what if it's in standard form? How do I take it from standard form and put it into vertex form if this form is so much better and going to make my life a lot easier? So there's 2 ways to go about doing this. And for me, depending on the way the problem is set up, I might go about one way versus the other. So typically what you're going to do is this method on the left. So last week we talked about how to complete the square to solve a quadratic equation. Now we're going to talk about how to complete the square to write a quadratic function in vertex form. And the process is really similar. The first thing that we're going to do is we're going to look for what magic number or what number I'm going to put in order to create a trinomial that would factor to be a perfect square. Then we're going to add that value inside the box. And then here's the part that is different. What we did when we solved by completing the square is whatever number went inside that box, we added it on both sides of the equation. Well, we don't have 2 sides of an equation. In fact, we don't have an equation. We have a function. So what we're actually going to do is we're going to add it as we have done before, but then we are going to subtract it from our constant. So let's look at this example below so that I can kind of explain what I mean there. If I was going to complete the square, here my b value is 2, half of 2 is 1, and if I square 1, I get 1. So normally right now we would say add 1 on both sides of the equation. But it doesn't make sense to add 1 over here. We're saying 1 plus the function. That's just really bad syntax, really bad notation. And the reason that we did that before is because we needed to make sure that we kept our equation balanced. If we did something on one side, then we needed to do the same thing on the other side. So how can we compensate for that without modifying anything on the left-hand side of the function? And here's how you do that. What I'm doing right now is I'm changing this equation by adding 1. If I also just subtract 1 on the same side, what I'm doing is saying that positive 1 and negative 1 is 0. So I have not changed the value or the total sum of what's happening on the right-hand side. I have just rewritten it in an order that allows me to factor. So anytime you're going to add that value, whatever that number is, you're also going to subtract it from your k value, or sorry, from your constant that's going to be on the outside. Then you can rewrite that as a perfect square, which is going to be x plus 1 quantity squared, and you're going to combine like terms over here. 5 plus negative 1 is 4, which again allows us to say that the axis of symmetry is x equals negative 1, and that the vertex is negative 1, 4. So that's option 1. It's the most straightforward. It's the one you're going to use more often than not. But as you may have noticed, sometimes complete the square can be a little bit more complicated. We haven't really talked about what happens if we complete the square and there's a number in the a spot that isn't 1. We haven't really done too many examples where the b value that we're completing the square with is an odd number, such as 5. That would be much less fun to sort of have to cut in half and square and do that fraction work. So there is another method that we can go about using in order to write a quadratic function in vertex form. And that process is going to look kind of similar to what we did to find the axis of symmetry in vertex before we actually knew what vertex form was. You're going to find the axis of symmetry in the vertex, so using x equals the opposite of b over 2a and plugging that in for the vertex. That means that you just figured out what h and k are, which means you can plug those into vertex form. Then you need to find any other point. The easiest point is going to be the y-intercept. And plug that in so that you can figure out what a is. And then you're going to rewrite in standard form. So I'm going to go through both of those examples, both of those styles, on the next set of problems. So, okay, for problems 4 and 5, we have nice even b values and our a values are 1. So I don't think we're going to have any issues completing the square the way that we did before. On problem number 6, I'm going to show you both methods for solving. So let's start with number 4. The very first thing I want to do is figure out what value I need to add to both sides to complete the square. So what I'm going to do is rewrite that so I have space to figure out what that value is that I'm going to add to both sides to complete this square. Now, if you don't have any idea what completing this square is, you should go back and watch that video because it's really an essential part of what we're doing in this video. So my b value on number 4 is 16. If I take half of 16, I get 8. And if I square 8, I get 64. So 64 is going to be that number that I'm adding. Now, if I add 64 on the left-hand red box, on the right-hand red box, I need to subtract 64. I need to do the opposite so that the two red boxes add to be 0. By making the two red boxes add to be 0, that means I have not at all changed the equation. I have really just added 0 to it, which means that it is exactly the same as it was before, even though it's going to look slightly different. So now what I'm going to do is I'm going to factor that x squared plus 16x plus 64 to be a perfect square, and I'm going to combine like terms with 71 and negative 64. So when I factor that, I'm going to get x plus 8 quantity squared. 71 minus 64, or 71 plus negative 64 is going to be 7. So here I now have vertex form, which means I can identify my vertex, which is negative 8, 7. Also, on a couple of your homework problems, you're going to be asked what the value of a is. A is just going to be that value in front, which in this case is 1 because there is no number in front. Okay, let's look at example number 5. So I'm going to start by rewriting it so that I can figure out what that value is that I need to add to x squared plus 6x in order to complete the square. So looking at my b value, b is 6. I'm going to take half of 6 and square it. Half of 6 is 3. 3 squared is 9. So 9 is going to go inside the red box on the left. In order to keep this equation, this function balanced, if I'm adding 9, I also need to subtract 9, again, so that those two boxes add to be 0. Now I can factor the trinomial that is the perfect square, and I can combine my constants. X squared plus 6x plus 9 is going to factor to be x plus 3 quantity squared. Negative 12 plus negative 9, or negative 12 minus 9, is going to be negative 21. So again, if I was being asked to find the vertex is negative 3, negative 21. If I was being asked what h is negative 3. If I was being asked what k is negative 21. If I was being asked what a is the number that's in front, which is 1. Now we're going to look at our last problem. The big difference here is that in order to complete this square, I can't have negative 2 in front of my x squared term. Because if I tried to factor that, negative 2 is not a number where I multiply something by itself and I get negative 2, at least not in a logical, non-radical sort of way. So the way that we can deal with that is that we can, and again, we're kind of ignoring negative 37. We're leaving it over there by itself. We can factor out that a value. So this is exactly the same as saying negative 2 times x squared plus, if I divide negative 16 by negative 2, I'm going to get plus 8x. And I have not actually changed anything with the negative 37. I'm not factoring the negative 2 out of the negative 37. It's just staying in the back. So nothing in purple has changed from the original equation. Now I can complete the square. I need to figure out what number is going to go here and what number is going to go on the outside. So b is 8, half of 8 is 4, 4 squared is 16. Now this is the tricky part, and this is the part that when I show you the second method, you might understand why you like that method better. I'm not actually just adding 16 to the right-hand side of the equation. What I'm adding is, if you think about, if you distributed this 2 out, I'm actually adding negative 32. Negative 2 times 16 is negative 32. So how I have changed this equation is I have added negative 32, which means I need to do the opposite of that. If I added negative 32, I also need to add positive 32, so that negative 32 and positive 32 are 0. Now that's the trickiest part of doing a problem like this. The rest is not so bad. My negative 2 is still going to stay in front. My x squared plus 8x plus 16 is still going to factor to be x plus 4 quantity squared. And I'm still going to combine these terms over here. Negative 37 and positive 32 is going to give me negative 5. So my vertex is negative 4, negative 5. And again, that 32 is coming from the fact that not only did I add 16, but I also originally factored out that negative 2. So I need to multiply that negative 2 back in to figure out how I have actually changed the equation. So that's option 1 for how to write a function in vertex form if there's an a value that's not 1. Now I'm going to walk through this last problem in a different way. What you would have done before on problem number 6, if I asked you to find the axis of symmetry, is that you would have said, okay, let's look at the opposite of b over 2a. So in this case, looking back to this problem, the opposite of negative 16 is 16 over 2 times negative 2. 16 divided by negative 4 is negative 4. So we just found the x value of the vertex. In order to find the y value of the vertex, we would simply plug in negative 4. So f of negative 4 is negative 2 times negative 4 squared minus 16 times negative 4 minus 37. I'm going to just tell you that if you do all that math, you're going to end up with negative 5. So we now have our vertex. So what we just figured out is that to write in vertex form, we just found our h and our k. The only thing we don't know what it is yet is what a is. So let's go ahead and substitute in negative 4 for h and negative 5 for k. So we've almost completely written this in vertex form. The only exception is that we need to figure out what a is. Well, in order to figure out what a is, what we need is an x and a y value that we know is on this parabola, on this quadratic, that we can substitute in to solve for a. The easiest way to think about this is to figure out what the y-intercept is. So if I look back way over here, sorry, my work got really messy. Let's think about what happens if I plug 0 into this function. If I plug 0 in, everything goes away except for negative 37. So my y-intercept is 0, negative 37. So we can use that point, substitute in 0 and negative 37, and we can use that to solve for our a value. So 0 plus 4 is 4. 4 squared is 16. So we're going to have negative 37 equals 16 times a minus 5. Then we can solve for a. Add 5 to both sides and divide both sides by 16. That's going to give us that a is equal to negative 2. And then we can rewrite vertex form plugging in a, h, and k. And that's actually going to give us this exact function that we already found using the other method. This lesson was a lot to take in. Make sure you stop by office hours and get some help. Watch this video again, pause, rewind, do what you need to do. But this idea of vertex form is really going to help you in future classes.